So our next topic is the circular motion. Circular motion, uniform circular motion. So let's discuss that. So what is basically uniform circular motion? Uniform circular motion is a motion of a body moving at a constant speed. Constant speed is called uniform circular motion. That a body is moving in a circular motion but at the same speed, uniform circular motion. You can take the example of fan. Fan can be the example. If it is in a circular motion, so as you guys all know, that will have a lot of things like if angular displacement, angular displacement, angular velocity, angular acceleration. If a body is moving in a constant, you can say that the uniform circular motion. So this body will be having all these things. And why we are putting angular? Because this is a moving body. Okay. If there was a linear displacement, linear velocity, linear acceleration in the previous chapter we have discussed, that was what? That was not a moving body, that was linear. But here we are talking about angular just because of the moving circle in the circular motion. Means in the moving body is in the circular motion. Okay, so you can take the example of the fan too. So as you guys all know now, the uniform circular motion means a body is moving but at a constant speed. As you can take the example of the fan, a fan is moving at a constant speed. Okay, and they are moving circular, so that is the example of the uniform circular motion. So uniform circular motion is having a angular displacement. If a body is moving with a uniform circular motion, it will be having an angular displacement, angular velocity, angular acceleration. So in this video we'll discuss about the angular displacement, and in the other video we will discuss about the angular velocity, acceleration too. So now if we talk about the angular displacement, so what does it mean in actually? So angular displacement means that, for example, I'm having a body. For example, you can take the example of angular. First of all, let me tell you guys that what is angular displacement. With the help of diagram I'm telling you. So the angular displacement is covered when a body is moving, as you guys all know. If the circular motion is there, so angular displacement there. So the angular displacement is when the body is moving. Okay, so for example, a body is moving. As you guys all know, this is the radius of a body. Okay, this is the radius of a body. This is a position 1 of a body, and a body after some time body move here, and this is the position 2 of the body, and this is the radius of the same body. So here you can see this same, you can say that the body is making an angle here, theta here, that is called the angular displacement. Okay, so with the help of definition you will understand more clearly. So a body move at a circle, okay, at a circle, and move from position 1 to position 2, and produce an angle, that angle is called the angular displacement. Okay, as you guys all know, displacement is what? Displacement distance. Okay, shortest distance. So and angular means a moving body. So means a moving body is angular means it is making angle, and it is a moving body. So as you guys see, it's from the word you can understand that what does it mean in actually. Okay, so if we talk about this distance, the moving body has covered position 1, as well as this is at the point 2. So the distance between that is called the arc length. arc length, which is denoted by the S. Okay, so distance between the 2 points is called the arc length, which is denoted by the S. Okay, and arc length is what? Arc length is the distance. Okay, so for example, I'm having a two bodies. Okay, two circular bodies with the same shape. For example, this is a body, this is a body. Okay, same shape, same. Okay, a body is at this point. After that, sometime the body is moved at this point. Okay, this is the radius and this is the radius. So this is the angular displacement as well. This is the arc length. Here you can see that this is a body 1, position 1. That was a body 1 was at position 1.1. After some time the body moved at this position 2 at this point. So we have wrote here the position 2, and this is covering an angle 2. So after that, here you can see that this here is a radius and here is also the radius. Okay, so after that you can see that this is the, so here you can see that the arc length of this is body 1, this is body 2. Here you can see the arc length of a body 1 is quite smaller than the arc length of the body 2. So here you can understand that arc length, that is S, is greater of the body 2. So we can write here that the arc length is directly proportional to the theta, that the angular displacement will be more. So the, you can say the arc length will be more. You can say the angular displacement is more, so the arc length is more. Here the angular displacement is less, so the arc length is less. So you can write here that the arc length is directly proportional to the theta. Okay, so here you can see this is the proportional side. If you remove that, there is a constant. So there is the constant and the angular displacement, that is a constant radius. Constant radius is the constant. Okay, so if we have to find the theta, so we can write here theta is getting multiplied, it will get divide here. Okay, so we can write here S upon R. Okay, so this is the formula of the angular displacement. As you guys all know, we have to find the formula of the angular displacement. So angular displacement is denoted by the basically a theta. So theta is equal to the S upon R. Okay, if we talk about the SI unit of this, the SI unit of the angular displacement, that is, for example, we are having this. So again, this is the distance. Arc length is what? Distance. So the SI unit of distance is meter. If we talk about radius, so radius is also having a SI unit meter. So meter into meter cancel. So there is no unit of the angular displacement. But we consider at some point the unit as a radian. Radian is basically a supplement unit, but we consider that as a unit of the angular displacement at some point. Okay, so this radian, we are considered that as a unit, and we are having two more unit of the radian, of not at the radian, we are having two more unit of the, you can say that the of angular displacement. So other two unit we are having, that is the degree, okay, and a revolution. What is revolution? Revolution means a complete circle. A complete circle, that is called the one revolution. A complete circle, that is called the second revolution. Okay, so if we talk about that, the one radian, so when radian is equal, when the arc length and radius are equal. For example, I am having a, here you can see that the arc length is 10 and I am having a radius 10. So we are having a formula, that is theta upon theta is equal to r s upon r. So you can say this is 10, this is 10 given, so this is 1. So here you can see that the radian is equal to 1 when the arc length as well as the radius is equal. Okay, so we are having two more in revolution and the degree and the revolution. So angular displacement will be 1 at the degree when the s is equal to r, which means that the arc length is equal to the radius, that is considered as theta as a 1 radian. Okay, so as you guys all know, now we are having a radian as the and the degree. So let's find the relation between the between radian and the degree. For example, we are having that a 1 meter is equal to the 100 centimeter, 1 hour is equal to the 3600 seconds. So these are the constant values we are having. Okay, so to find the constant values, that 1 radian is equal to the how much and 1 degree is equal to how much, so through that relation of these both we will easily find. Okay, so from one revolution, like for example we are having for one revolution. Okay, so you are having for one revolution, so for one revolution we are having a complete revolution. As you guys all know that this is the distance, so this is what, this is the pi, this is the pi, so we are having 2 pi r, 2 pi r, this is the 1 pi, this is the 180, and this is 180, this is equal to 360. So we can write here that the S is equal to 2 pi r, circumference is equal to the 2 pi r, this is circumference, and we are having a 2 pi r formula of the circumference. So arc length will be equal to the circumference of the circle for the one complete revolution. Okay, so we are having a formula, we are having a formula of the, you can say, the angular displacement. We were having a formula that was S is equal to arc length is equal to r theta. So we can write here S is equal to r theta. Okay, so here you can see that we are having a S is equal to 2 pi r, 2 pi r is equal to, here r, and theta we are having 360 because of the circumference, so we can write here 360. Here you can, r is cancelled by r, so only 2 pi r, 2 pi radian is the unit, as you guys all know. So radian is equal to 360. This is what, this is the formula of the one complete revolution. Okay, the 2 pi r, and this is what, 360, so this is the revolution, so this is the same formula. Okay, so for finding that for 1 radian is equal to how much, so that's, let's find that. So for 1 radian, as you guys all know, we have to find the radian. So here you can see 360 is getting multiply 2 pi r is here, so it will move downward, it will get, you can say, the divide. So here you can see that we are having a 1 radian is equal to the, we can write here that 360 upon 2 pi. Okay, so here you can see that 360 and 2 pi, as you guys all know, 2 pi r, we are having a 3.14 value, so multiply this, you will get 6.28. So we can write here 6.28. So after dividing that, you will get that 1 radian is equal to the 57.3 degree. Okay, so here you can see that when a body moves with this angle, which means that it has covered 1 radian, so 1 radian is equal to the 57.3 degree. So now we have to find what, now we have to find the degree for 1 degree, that how much 1 degree is equal to. So if you talk about the 1 degree, so here you can see that the, here the, we have here 360 divided by 2 pi r, so the 2 pi r will, 2 pi will divide by the 360, so we can write here 2 pi for degree is 360 radian, which is equal to the 1 degree, as you guys all know, we have here, we have written. So here you can see that the 2 pi we are having, that is 6.28, here we have find it out. So here upon 360 is equal to 1. So if you will divide these both, you will get the, that 1 degree is equal to 0.0174 radian. The radian is a unit, so this is the unit. So 1 degree is equal to the 0.0174. So 1 degree we have find it out, 1 radian we have find it out, as well as I have told you guys about the unit and formula of the angular displacement. So today we have covered the angular displacement. In the next video we will discuss about the angular velocity.